Now we're going to be graphing hyperbolas in vertex form. We have two different types of hyperbolas. One is where the x is first and the x is positive, and those hyperbolas are going to look something similar to this, where they're going to the left and to the right. Then, whenever our y is positive, or y is in the front, then what's going to happen is the hyperbola is going to go up or down. Now notice that the hyperbola looks like two parabolas going in opposite directions. That's kind of what they are. Now, in order to graph them correctly, what we're going to do is we're going to be drawing asymptotes that are diagonal. How we're going to do that is we're going to make a box, and then we're going to draw the asymptotes diagonally through the box. In the same way, when they're going up or down, we're going to be drawing asymptotes that are diagonal. So this is the process of doing it. Now, before we graph the hyperbolas, what we're going to be doing is we're going to be writing them in vertex form. This is similar to what we did yesterday. We're going to look at the x's, we're going to look at the y's, we're going to see if there's anything that we need to factor. So with the x's, we're going to find our new c value. So we're going to take the -2, divide it by 2 and square it, and we get 1. For the y's, we're going to factor out a -4. We're going to get y squared minus 2y. We're going to find the new c value for y also. Take the -2, divide it by 2 and square it, and we get 1. And that's equal to 4. Remember, we're adding a 1 here, so we add 1. Adding a -4 here. Now what we're going to do is we're going to factor it. So we have x minus 1 squared. We have -4. And we have y minus 1 squared. 4 plus 1 is 5, minus 4 is 1. Now, something's a little unique about this one that we haven't discussed. What I'm going to do is I'm going to divide everything by 1. Now, you may be thinking, well, it's already said equal to 1. Why are you dividing it by 1? And that's to kind of show something unique with the y's. If we're looking at the x's, we've done this before where there's a 1 underneath. But with the y's, if we're looking at it closely, notice that nothing divides these. So what we have to do is something a little bit unique. We're going to write it as y minus 1 squared. And then what we're going to do is we're going to flip the 4. So the 4 over 1 becomes divided by 1/4. Now, the reason that this works is because when we divide, we multiply something by the reciprocal. So if you're looking at this bottom part, if we were to divide this by the reciprocal of 1/4 is 4. So we would multiply each side by 4. And that's how this right here looks like that one right there. Now, what we're going to do is we're going to graph. We're going to graph this similar to what we did with the ellipse. We're going to put down our center, which in this case is 1, 1. And so we're going to plot our 1, 1 right here. Next thing that we're going to do is we're going to take the square root of our a and b values. The square root of 1 is 1. So we're going to go to the right and to the left 1. And the square root of 1/4 is a half. So we're going to go up a half and down. Now what we're going to do is we're going to put an imaginary box. And this right here is to help guide what the asymptotes look like. We're going to take the center and we're going to draw an asymptote from the center to the corner. And that right there is one asymptote. And do that for each of the corners. Now what we're going to do is we notice that the x is positive. So whenever the x is positive, The hyperbola is going to go to the left, and it's going to go to the right. And that right there is our graph. So let's look at letter B. With letter B, we're going to get the x's together and then the y's. So we have negative 4x squared plus 24x plus 9y squared minus 36y is equal to 36. I'm going to factor out a negative 4, and I get x squared minus 6x. I'm going to complete the square, so I'm going to take the negative 6, divide it by 2, and square it to get 9. Then I'm going to factor out a 9, and I get y squared minus 4y. I'm going to divide it by 2 and square it to get 4. And that's equal to the 36. Negative 4 times 9 is negative 36. And 9 times 4 is positive 36. So now I'm going to factor. I have negative 4. I have x minus 3 squared. Then I have 9y minus 2 squared. And that's equal to 36. So I'm going to divide everything by 36. And you may have noticed that the x is negative. So what I'm going to do is I'm going to switch them. So I'm going to put the y first. Notice that the 9 and the 36 cancel, 1 and 4. So I have y minus 2 squared over 4. I have minus 4 and the 36 cancel. So that gives me x minus 3 squared over 9. And that's equal to 1. So the center of my hyperbola, I'm going to put the x first, which is 3. I'm going to put the y second, which is 2. So I have a center at 3 and 2. Notice that the y value is positive, so I know that it's going to be going up and down. And what I'm going to be doing is I'm going to move the center, or I should say the x and y axis, over just so I can fit it on our graph. So I have a center at 3, 2. So that means I'm going to go to the right 3. I'm going to go up 2. And I'm going to take the square root of 4, which is 2. Since it's below the y, I'm going to go up 2 and down 2. With the x's, the square root of 9 is 3. So I'm going to go to the left 3 and the right 3. Now, I'm going to make my imaginary box. And this imaginary box, once again, helps me with the asymptotes that are diagonal. It helps guide it so I get an appropriate. The asymptotes are going to go through the center and the corner of each one for a rectangle. Now, once again, how I determine if it goes up or down or left or right is depending on which one is positive. So notice that my y is positive, so that means that I'm going to go to my y points above the center, and I'm going to follow the asymptote as closely as I can without crossing it. And that right there is my graph.